Can you hear me? Yes. Yes, I can. Try this. All right. That should probably work. Question mark. All right. Let's give it a go today. For whatever reason, that's not working. Hello? Okay. Yo, Granite, how we doing, buddy? Hope we're doing well today. I'm gonna turn my mic down just a smidge. Might be a little bit too loud. How we doing today, my man? How was your weekend? Hopefully your weekend was good. Yeah, good. All is good in the world. Wonderful. That's wonderful to hear. Can you? I'm hoping that my microphone comes in through okay. I'm using a new microphone, so hopefully it sounds okay to you. Maybe my voice is a little gravelly. I don't know. Yeah, back. Hey, welcome back, Beast. I'm doing. I'm doing good, Beast. I'm doing good. First day back of school after having to isolate for 10 days. Oh no, man. You caught the COVID, or did you get? Yeah, you were contacted somebody. You can call me anything. This is true. That trust me, Beast. I'm not insulted by it whatsoever. I did say that, and I'll stick to my guns. So, granted, were you like in contact with somebody who had COVID? Right? You had to isolate for 10 days. Yeah. Oh, that's right. That's right. I remember you saying that. It was like a week ago. Well, I'm glad all is fine now. Hopefully everything came back negative and you'll be able to get on to doing what you need to do at the end of the day. That's not fun to isolate for long stretches of time. No lie. But if all is fine, then that's good. It was a positive test. Ooh, bummer. Yucko. Well, that's no fun. Yeah, I wouldn't like that either, to be honest. I just kind of played Destiny 2 a lot. I see. It all came down to Destiny 2. Gotcha. I can respect that. I play Overwatch. I'm so sorry. Why do you play Overwatch? Oh man, that's such a bummer. I used to play Overwatch and then I stopped. I'm sorry. I'm sorry, but it's true. Overwatch is just not good anymore. Look, the game died to me after I tried competitive, and then when they changed casual over to role based stuff, yeah, it was just like, man. Yeah, you watch the league and everything. I respect that. I know the league is dying, you know, but you're not a paid fan, are you, Beast? I'm a little worried. I'm just saying. You're not one of those paid fans. League has no sponsors. They have no sponsors now. None. Oof. Yeah, I know why they lost the sponsors because of all the Blizzard stuff. Yeah. Look, it's Blizzard's own fault. They made it themselves. Yeah. With all the Blizzard lawsuit stuff that was going on, yeah, it was only a matter of time before they lost everything. It was just a matter of time. I don't know why I can't hear any music. I can hear music through my headphone, but I can't hear it through the output projector. That's why Scar isn't. Yeah, exactly. Honestly, if you think about it this way, right? Like look at it this way. Like the day that like things started to go downhill pretty early on. But when like when XQC was kicked out, right? When XQC was kicked out, then the thing started to kind of go downhill after that. Then people started to figure out, yeah, yeah, that's true. Say Bailobi, yeah. It's just unfortunate. They didn't let the players actually have their own kind of personality. I really like that about players is when they bring in their own personality and you really could connect with that player and then you start to root for them. That's what happens in yeah, like Seagull too. Like Seagull left because it just he could make more money doing streaming, and he could make more. He could just be himself, doing his own streams. It'd be something akin to that. The problem is that at the end of the day, you need to let players have their own personality and bring it to the forefront. That's how you market yourself so well. You can't just be like, oh yeah, well, you have to follow this rule, that rule, and this rule. Yeah, I agree that there should be some rules, of course, being in the league, but I mean, I mean, yeah, not to that large degree. I think that they felt very restricted, and I don't blame them for doing that. The Overwatch community is so small, like yeah. Eventually, that's how communities will get, once things start winning in popularity. Everybody pretty much gets to know each other. Like I played an MMO that has like a player base of like an active player base of this is way back in the day. Had an active player base of like a few thousand, and everybody kind of knew each other on both sides. So, Isabella, hello, good morning to you. You play Overwatch? I'm so sorry too. I'm so sorry you play Overwatch. I'm so sorry. Nah. D2 is. There's a lot of. I see the debate is going to keep rolling on here. D2 is the best FPS experience, is where it's at. I mean, like I said, everybody in this chat, everybody in Twitch, everybody out there who's a gamer has a particular community that they're very fond of and that they want to be a part of. I'm currently part of the Final Fantasy community, but that could easily change. You know. All right. Oh, you got tennis, my man? All right, no problem. All right. I hope you have some fun there, Beast. Devs 2 make original Halo games, need I say less? Tis true, tis true. I mean, I won't. It all comes down to game design, replayability. Is there replayability in that game? And then you could start coalescing a community around that. I think Destiny 2 definitely has a replayability for a lot of people. So I think that's a very yeah. I think granted that's a very fair thing to say. A lot of people who play D2 says there's just loads and loads of replayability on it. It's like Skyrim as well. Skyrim even to this day, over a decade old, but still has hundreds of hours of replayability that you can go and explore in the game. So Sneaky Weasel, hello. How we doing today? Good morning to you. How are we doing today? I. And Sneaky Weasel says I. Good morning, Jasmine. Good morning. How are you doing? I'm pretty good. I'm doing very good. Doing very good today. As you can tell, I have a new microphone, so no longer will I be using the headset microphone. It is now just the Yeti microphone that's sitting to my right. So hopefully this sounds a bit better, and things will be less in my way. So that'll be actually kind of good. So. Hey Connor, how we doing? Yeah, absolutely. You can lurk all you like. The pockets might. Yeah, yeah. It was relatively inexpensive compared to other pieces of technology. This was like $100 on sale, so I was like, oh, okay. Well, if it's $100, I'm not gonna say no to a nicer mic. That at least will help have you guys hear me slightly a bit better. Slightly better. Connor W, good morning. Good morning to you. How you doing this morning? How are we doing this morning? It's a rare time I'm doing math while you're, yeah. It is. Hey, Eugene, you got done with work early at school? Of course, Eugene. Naturally, you can join in. Of course. You're more than welcome to come in on at any time. This is for Math 120, but, you know, absolutely. But big, wow. Isolated for 10 days playing Destiny 2. I had no idea you're playing Destiny 2. I had no idea. This was the shocker of the shocks. Let me tell you. Now, I don't know why my audio is all messed up. It's kind of weird. See if my audio is not working. So I apologize if you just hear the microphone today. For whatever reason, none of this stuff wants to work. So shocker of the century. Right? It's true. It's true. What is going on with this thing? This thing just not... Maybe I noise gated this too much. I don't know. I have no idea. Well, we'll figure it out someday. All right. In any case, bear with me here today, ladies and gentlemen, as I have a few changes. I had a few changes here on this setup thing. All right. You know, there's nothing wrong with that. Over the funny maths man. I'm a little worried now. Now you have me worried. I can do it this way. Let me see if I can do it this way. Hang on. Let's see if this works. Let's see if I can plug this in here. Trying out different things here today, guys. So bear with me. Bear with me, folks. Is there a thing here? It's a sign, you know. It's a sign, you know. Here. Try that. That worked. Does this work automatically? This would be great if it does. The answer is no. All right, Sag. All right. Guess that'll have to do it. All right. All right, someday. Guess that way. All right. In any case, I guess no music today. Apologies. I guess I can only hear music, which is not good, but it is what it is. All right. We'll see if it works somehow, some way. I don't know. Okay. All right. Change this to this. Okay. All right. I know it does help you focus in a way. I'm apologizing ahead of time. Have a separate tab. I do have a separate tab open for YouTube. I do. I really do. Like, it's open right now. Like, it's seriously, it's open right now. I'm playing the music. I could hear it through this guy, but I need it to translate to the stream so you guys can hear it. That would be ideal. And I don't know why it's not working. You heard it for a second? Okay, let me see. I don't know if I've... Oh, there we go. Oh, it was too low. Holy snaps. Okay, give me a sec. There it is. Alright. I need to turn this down. This is like way too loud for his stream. Alright. It was just the volume. Oh, that's so weird that the volume changes automatically. Alright. Now let me make adjustments here. You guys deserve it because you guys asked. I need to make adjustments. Give me a second, guys. And we'll get going. You're kidding, right? No way. No way. Thing is at like 23 volume. Holy smokes. Really loud. I don't want to put it that too loud. Okay, how's that, guys? How's that? Is that okay? Everybody okay with that? That volume setting? Or should I put it, do we need it a little lower? You guys gotta let me know. That's good. Louder? Okay. How's this? Like, there's gonna be varying sounds of the volume there. Bruh. Okay. Ah. How's that? That pretty decent? That's good? Okay. Alright, let's see if that... Yeah. Alright. Well, we'll tweak it as we go along, so... I can't give you any guarantees, because it'd be a lot easier if I had the other setting, but whatever. It is what it is. Okay. You guys can hear from time to time, and that's okay. That's not a problem. Alright. Spending way too much time on this. Alright. Let's move on with our lives. Alright, let's do this. We got some stuff to do. Alright, I promise you we got stuff to do. As long as it works okay. Yeah. Okay. Alright, let's do some intros, ladies and gentlemen. And let's get started here. Alright. Okay, let's get started today. Welcome back, everybody, to Tuesday. Hopefully, a nice weekend. All right, so for today, ladies and gentlemen, we're going to be continuing to move on here within Chapter 5. All right, so within Chapter 5 here, we are going to be continuing with our stuff. All right, so let's go ahead and move forward with that. Now, I believe, remind me, guys, one more thing. I believe I set the due date here for this Thursday. Was it this Thursday I set your due date? Or was it last Thursday? I kind of forgot. I got two classes going on at the same time, but I think it's the 30th that I set the due date here. Yeah. So it's the 30th here. So as a friendly reminder, remember the 30th there for chapters 1 through 4. Yeah, I figured it was this Thursday. My 102 class got last Thursday, so that's why I'm just kind of asking you guys really quick. So, yes, this Thursday is when your test for Chapter 1 through 4 is due, along with the homework, so be sure to finish it up by then, so that way you get that taken care of, and you don't have to worry, and things will be less sedge, alright? So, we'll be in good shape. Good stuff. Alright? So, no problems there. Alright, so, let's talk about what we are going to be covering here today. Alright, so today... we're going to continue where we left off last time. If you recall, last time we talked about section 5.4. All right, and we did talk about up to a certain point. We talked about conditional probability. We did some examples with that, and all well and good. That was pretty nice and stuff like that. But today, what we're going to be doing is we are going to be doing the second half of section 5.4, which we didn't get around to talking about here. Wait, hang on, Vince. I'm close to 800 followers. Wow, go figure. That's a lot of hostages. I mean students. Pardon me. Sorry, I almost spoke wrong there. You didn't hear anything about that. Um, anywho. All right. So today we're gonna do the second half here. Now, one thing we didn't talk about here last time is we did not talk about like using the general multiplication rule and using with or without replacements. So we're gonna do some examples using that, as that also is tied into conditional probability as well. So let's go to the big board here, and let's go ahead and take a look. All right. Okay, so we're going to start off from the previous handout here, and this has stuff to do with number 5. So let's look at number 5. I'm going to answer number 5 and number 6, and we're going to do some various examples that kind of go along with that here. And you guys will, of course, follow me to the promised land, and hopefully we'll get the correct answer here at the end of the day. All right. So what is the general multiplication rule? Now, we did talk about the variation of that, which was the conditional probability. We did talk about that last time here. So as you can see here on the screen, the probability of B given A was the probability of A and B divided by the probability of A. We did a couple examples there with the table, okay, and we saw how that kind of works out. Now, you could also use the general multiplication rule here, and you could say, well, what would happen if we use that same formula here? You can do some simple algebra. In this case, it's just an alternative form of the probability of A and B. It would be the probability of A times the probability of B given A. Now, admittingly, this is a super general form, and it doesn't look like we actually use this at any point in time. But in actuality, we do. The only thing is that we just use logic to essentially apply this rule as opposed to use, say, directly using a given probability, kind of, sort of. Okay, in any case, where do we exactly use this rule a majority of the time, and where exactly is this, for example, this logic is going to apply for? So where we use this is we use this as with sampling with or without replacement. Now, basically, with or without replacement. Hey, Gulmesh, I'm doing good, my friend. Now, what is with or without replacement? Now, sampling with or without replacement is exactly as it sounds, all right? So sampling with replacement here is basically you replace the item back. So you get the same amount of items for each pull. So for example here, if I had a deck of cards and I ask you, hey, can you, take out a card from the deck of cards? I ask you pull out a card from the deck of cards. I said, okay, you look at it, and then you put that back in the deck. That is going to be, essentially at the end of the day, that is going to be what you do there. You replace it back in the deck, and I still have the same 52 cards as I had from before. Without replacement says, okay, can you pull a card from the deck of cards? You pull out a card, you keep it in your hand, and then you don't put it back in the deck. All right, and now I have 51 cards left over in my hand instead of 52. Okay. And of course, probabilities are going to change depending on if we have replacement or we have without replacement. So that's going to depend on what we have there. So let's take a good look here and see exactly what we're working with here. And we'll get that squared away. Okay. If the music's too loud for you guys, I'll make adjustments. Like I said, kind of up and down here with the music stuff. Okay. All right. Let's do it. All right, so we're going to go to a book problem here. And let me bring out the... Actually, let me put this on a half and half. Okay. I know it keeps cutting in and out. I haven't quite figured out the volume balancing there yet, Jasmine, for some reason. I'm not sure why the volume is kind of all over the place. So like on my setting on my computer, it's at 100. And then my application, it's kind of weird. I'm not sure why. I can always switch to another. Actually, if If you want to, I could just switch to another one and see how that works. So hopefully this will be a little bit more consistent. I have no idea. I'm guessing this works. So if it's a little bit more consistent, then I guess it's maybe just the video? Question mark? I don't know. We'll go with this. Let's see how that works. Yeah, I just need to get it to be like a little bit more consistent. All right. I know it sounds super awkward. Let me try it one more time, actually. This needs to be 30. Okay, that's slightly a bit better. Oh, okay. I think I got it. Hang on. I think I got it, folks. I think I got it. I think I got it to work. There we go. Alright. There we go. I did get it to work out. A smidge. Better. Why is the I think it's because I added the new microphone, so of course anytime I mess with stuff it just messes up my settings. So to be fair, that's not anything on you. That's just stuff on me. So, you know, I'm not blaming anybody but myself. That's just how it is. Alright, that'll work, I guess. Alright, that'll work. Okay. So, hopefully that's a slightly bit better with fewer cutouts. We'll just have to lower that down. Alright. So, okay. Yeah, again, I'm no audio engineer. I'm no audio engineer, Jasmine, to be fair. I'm no audio engineer. I'm just a regular dude that just has a regular computer. That's about it. So, I'm just a layman. So, if there are people who have better explanations than me, I'm pretty sure you can find it from them. Oh well, no biggie. Alright, I think I got it worked out though. Alright, in any case. Alright, so let's go ahead and take a look here at number 27. So we're going to look at 27 here. And we're going to go ahead and read this off here together. And we'll see exactly how this works. Again, with or without replacement, just depends. Alright, so let's read this off together here. So suppose that a digital music player has 13 tracks. After listening to all the songs, you decide that you like 5 of them. With the random feature on your player, each of the 13 songs is played once in random order. Find the probability that among the first 2 songs played, you like both of them. Would this be unusual? Okay, fair question here. Alright, now let's take a good look here at how to do this particular problem. And this one's not too bad, it's pretty doable. Alright, but it just depends. Alright, so let's look at this one here. Now, all we need to do here for letter A is, again, let's put the scenario to test here. We have 13 tracks overall. So we have 13 tracks here on this, let's call it a CD or whatever, because I'm old school like that. Alright, so, and we like 5 of them. Okay, so 5 that we like here. Alright. Have a good one, Goldmash. Take care of yourself. So if I like 5 songs on this CD or whatever you want to call it, if I like 5 songs, then how many songs do I not like? How many songs do I dislike? If I like 5 out of those 13 songs, how many songs do I dislike here then? All right, so the answer indeed is 8. Okay, so 8 of them are songs that we absolutely do not like. So we're also going to make note of that here. We dislike 8 songs. So, you know, not every album by every artist is going to have every song be a banger. We all know that. So maybe there's just some songs you don't like or you don't find very enjoyable for you. That's fine. All right. But we listened through these songs here and we want to say, okay, let's say the first song here we like. Oh, you're right. Thank you. Again, this will be the probability we like both. There you go. So we have the first song and we have the second song. Okay. Okay. So if we like the first song here, we need to figure out the probability that we like the first song. Now, here's what's very important in this problem. Reading this carefully here, it says with the random feature on your player, each of the 13 songs is played once in random order. So every song has to be played once before you go back and have another random ordering of those same 13 songs. Okay, so they have to be played at least once. So essentially what that effectively means is that, and this is probably the most important part of the problem here, is that this effectively means that we are listening to these songs without replacement, okay? So this basically is implied without replacement. Okay. Again, just based on, it's not a true random shuffling, essentially. Once we listen to one song, we'll listen to another song, but it can't be the first song that we listen to. So we won't get the same song twice in a row. All right. Now, let's say it's the first song here that we have. Let's say the first song is a song that we like. Well, what's the probability that's the first song that we listen to is a song that we like? All right. That's correct. 5 out of 13. That's right. Okay. Very good. Spot on so far. Okay. Good. All right. So the first song we listen to, we really like it. We say it's a banger of a tune. Wonderful stuff. Okay. So, all right. Great. All right. So now that song's over. Now the next song plays. The second song plays. And let's say, once again, it's a song that we really like. What's the probability that the second song is the second song we like? 4 out of 13, you say. Oh, 4 out of 12, you say. Ah, very good. That's a good pickup there, Jasmine. That's right. 4 out of 12 is correct. So remember how this is like part of that conditional replacement, right? We now, and the reasoning that you have there is correct, right? Once we have played the first song, that's one song that's out of the pool of 13 songs. So now we have 12 songs left in the pool. Now, we've already listened to one song that we like, so we had 5 of them. Now there's just 4 songs left in the pool that we actually like. So hence the 4 out of 12 that for the second song that comes up to a song that we actually like at the end of the day. All right? So absolutely correct in that reasoning, 100%. And now we just go ahead and multiply both of these together, and we will actually get our probability here to work out easy peasy lemon squeeze. All right, so does anybody have a probability for me? 5 out of 13 times 4 out of 12, 0.1282. All right. Vince is on fire today. I like it. Vince drank his coffee this morning, and he's absolutely hitting that out of the park. All right, very nice enough. All right. I'm drinking my coffee too. I'm not as good as you. All right. All right. Very good. Any questions about that so far? Any questions? All right. That's fine. Okay. No questions so far? No problem. All right. Let's move on to the next part here. Let's look at part B. All right. So part B says we like neither song. So both songs we don't like. So again, we like neither. Neither, whichever way you want to say it. Okay, again, drawing this pseudo picture is actually fairly helpful once again. So again, we're going to have here, we'll have the first song here. Again, we dislike that song. And the second song is we dislike the second one. Buddy, don't try not to cut your finger open. Just be careful, okay? Just don't do what I did when I worked at McDonald's, Beast, okay? Just don't do what I did. I sometimes would cut my finger on dollar bills when I was cashiering. And so, yeah, I was once, you know, when you're handling bills and stuff like that, you're going to cut your fingers quite often, especially with newer bills. So what I would do is, in order to make sure that I didn't have to wear a Band-Aid or nothing, because, you know, I wasn't smart back then, I then took out a salt packet and put it on the wound. I was like, oh, that hurts. However, on the plus side of that, because of that experience, I have a higher pain threshold. So I guess there was a positive out of that. I have a much higher pain threshold than I probably should. Okay, so let's go over the first one here. Let's go over the first one here. What if the first song here is a song you dislike? What's the probability that the first song that you listen to is a song you dislike? Alright, so pretty easy stuff here. I totally agree with that. 100%. 8 out of 13. Alright. What's the second song that you have that you dislike here? What are the odds that you have the second song you dislike? So the odds that the second song that you dislike here is, what did Jasmine say? Oh, Jasmine said 7 out of 12. Okay. That is correct. Okay, good. So here we have 8 out of 13 times 7 out of 12. And as Jasmine has stated here, very appropriately, we get 0.3590. Good. Easy peasy, lemon the squeezy. Alright. Hopefully that's not too bad. Alright. We're just going to go up to letter C, by the way. I won't do letter D, because I have a different example for letter D. For non-replacement. Anyway. Letter C, you will like exactly one of them. Now, I will say this, for letter C, just really quick. You like exactly one of them. It doesn't matter which order you put it in, you will get the same answer regardless. So you could like the first song and dislike the second song, or you could dislike the first song and like the second song, and either way, you're going to get the same result. So just to let you know, for this question here in particular, it doesn't matter which order you go in, you will get the same answer no matter what. So that's why they're not being as specific in this one. All right, so let's just go with the premise here that we're like, okay, let's say the first song is a song we like, and let's say the second song is a song we dislike. Okay, so let's just do that. Okay, so let's go to the first song we like. What's that going to be? What are the odds that the first song we listen to is a song that we like? Once again. 5 out of 13. Okay, 5 out of 13 is correct. All right, so far so bueno. And what is the odds that the second song we listen to is the song we dislike? Ah, that's correct, Carla. Very good. That's right. So we have 8 songs we dislike. However, there are 12 songs left in the pool. So, not 7 out of 12 there, Vince. We had 8 out of 12 because we still have 8 songs that we dislike here. So we got to be careful about that second one there. All right? Again, since we're only exactly like one of them, got to be careful about what's left in the pool depending on the situation. So Sneaky says 5 out of 13 times 8 over 12, 2564. So that sounds correct. So 2564 will be your final answer for that. So just be a little careful. That's why I like to draw out these like kind of pseudo pictures here. That way you can keep yourself a little bit organized and it's actually a little bit easier to follow. All right. Questions? Yeah, no problem. No problem. We're here just to clear up stuff. No worries. All right, any questions about that, anybody? Hopefully that's pretty straightforward. All righty. Why do we have to multiply it with one we don't like? Because we like exactly one. In this case, you were listening to 2 tracks. So we're listening to the premise here, Jasmine, is we're automatically listening to 2 tracks. So whether or not it has to be multiplied because we still have to take the second case into account. It's not just one. When we talk about exactly one, we talk about exactly one, but again, is it the first track? Is it the second track? So we're under the premise we're always listening to 2 songs. If it was just one song, then it'd be like, okay, then it'd just be that 5 out of 13. That's it. Yeah. Yeah, that's fine. That's fine. No problemo. All right. Any more questions before we move on here? All right, I'll move on then. Okay. I'm going to move here to the next page. All right. So let's take a good look here at, I'm going to look at this next problem here, which is number 29. All right, so that's going to be our next problem here. All right, so number 29 states, planting tulips. All right, so a bag of 30 tulip bulbs purchased from a nursery contains 12 red tulip bulbs, 10 yellow tulip bulbs, and 8 purple tulip bulbs. All right, so what we're going to do here in this particular problem is in this particular case, we're gonna do this with replacement. Okay. So this I'm gonna put in the idea with replacement. All right. So essentially, what I'm gonna do is I'll reach into the bucket of tulip bulbs. I'll pull out one random tulip bulb. I'll make note of the color, and then I'll put that tulip bulb back into the bucket, and then reach in again and grab another tulip bulb and make note of that color once again. Okay, so that's all I'm going to be really doing here. So again, we're going to be doing this pretty much the same way, but again, looking at slightly different scenarios, of course, depending on probability. Let's go over a simple one here first and foremost. Probability that they're both red. All right, so let's go with that. All right, so the probability that they're both red. So let's take a good look here. If I pull out a red on the first pull, so I reach in the bucket, and I reach in, I pull out a tulip bulb, and I say, oh, well, it's a red tulip bulb. Okay. Well, what's the probability that that's red? Okay, 12 out of 30. Pretty simple, right? No problemo. Easy peasy. All right, so we have 12 red bulbs, and out of the 30 total tulip bulbs in this problem. All right, seems fair. All right, so I make a note of it. I said, okay, this tulip bulb is red. I toss it back into the bucket, and I then reach in, pull another one out. I said, oh, okay, now the second tulip bulb here is also red. What is the probability that the second bulb I pull here is going to be red? Are we going to pretend to do it twice for every problem? Well, doesn't have to be twice. In this case, that's the scenario here, Jasmine, but then it just depends. I could have 3 pulls, and then I'll have three probabilities I'll need to multiply together, Jasmine. So, again, just read every problem here. It could be 2 pulls, it could be 3 pulls, it could be 5 pulls. Again, it just depends on the scenario there, Jasmine. In this case, we're just pretending that it's 2 times because that's what it asks us to do. We have 2 randomly selected tulip bulbs in this case. So, 12 out of 30 again. That is correct. Very good. All right, so we have 12 out of 30 here, and yes, that is correct, Sneaky Weasel. That is correct. 0.16 is correct. Good. No problem. So far, so good. All right. You guys are doing just fine. Yeah, it does depend on the wording, right? It depends on the wording of the probability. If they told me, like if I told me, hey, what's the probability that 3 randomly selected tulip bulbs are all red, then I'll have 3 of these reds, and then I'll have 12 out of 30 3 times. And then I'll multiply that in this case. So, yeah, it all depends on what's written there. So one of the things that's very important to note here when it comes to mathematics is not to assume too much. Just look at what it's telling you and then kind of react to that and then see what you can do with from there. So, I know that could be hard though. All right, well, let's look at letter B. What is the probability that the first bulb is red and the second is yellow? So the probability that we get red and yellow. Red and yellow. So with each successive pull, we get red and yellow. Let's see what we get. All right, so here, the first one we get red, and the second one is yellow. All right, so the first one is red. What's the probability that the first one we pull is red? Once again. $12 out of 30, okay. Easy peasy, same thing. Now, what's the probability that the second bulb, so we take that bulb, right, toss it back in the bucket, we noted that it was red. I reach in the bucket again, I pull out, I say, okay, now it's yellow. What's the probability that the second one is yellow? All right, 10 out of 30, that's correct. All right, and what do we get here for our probability? If we multiply these together, what's our final result for this? 0.133 repeating? Okay. All right, so we'll go 4 decimal places here. So 0.1333. All right. Very good. Now let me switch this problem up just a smidge, all right? Let me switch this problem just a little bit. Let's go without replacement. So now I'm just going to change the scenario here. Let's say this time, though, I went ahead and I said, all right, I'm still going to pull 2 bulbs out of the bucket, but now I take a look at it, and I take a look at the color, and I put that off to the side. I put that first pull off to the side because maybe I'm going to actually go ahead and plant it, and try to grow some tulips of that same color. I said, okay, fine. That seems fair, right? So let's go with this scenario here. So I'll just call this letter C. This is not in the book, though. So let's say the probability of the first pull being purple, and then the second one being yellow. So how about purple and yellow here? So purple and yellow. But this time without replacement. Alright, so what's the probability that the first pull, I reach my hand in the bucket, I pull out a bulb, and it's purple. Alright, 8 out of 30, that's correct. Okay, very good. 8 out of 30 is spot on. Alright, nicely done. Alright, so I look at that, it says 8 out of 30, okay. Whatever, that's fine. But alright, here you go. Put it off to the side. There you go. Easy peasy lemon squeezy. Okay. So now that's off to the side. I reach into my hand in the bucket again. I pull out another bulb, and it is now yellow. It's the odds that I pull out a yellow there. 10 out of 29. All right. That is correct. I have 10 yellows in the bucket. I have 29 left over since I pulled that out. Alright, and if I multiply that together, I get... Alright, looks like I get a couple answers here. 0.919? I think that's a little high there, Sneaky. I know for sure it's definitely not 91%. I'm gonna try that again. The numbers are right, just, what's an... let me check that. Yeah, one of those is true. I just need to make sure that the rounding is correct. So... Okay, 9195, okay. Got it. 091, okay. Yeah. That was the only thing, yeah, to be fair, Jasmine, that's all I was checking, is that extra 5. So, since I got 2 answers there, I just have to be double extra sure. Alright, so it is 0.0920 is correct. Alright, very good. Because that extra 5 next to the last 9 there, that'll round it up to 20 instead of 19. So, alright. Very good. Very good. Alright, any questions about that? Any questions? Hopefully that's pretty easy now. Okay. Easy peasy lemon squeezy. Yeah, that bumps. Yep, it does bump the numbers too, so you gotta be just a little careful. That's all. No problem. Just take your time when it comes to rounding at the end, so you're not mixing up your stuff. I can't guarantee that, Jasmine. I can't guarantee that. All right. All right, let's look at the handout here. So now we're done with this handout here, which was section 5.4. That was the last part that we didn't get a chance to talk about last time. We're going to go over to section 5.5 here next. So let's discuss about that guy. All right, so let's talk about, there's got a lot of objectives here when it comes to 5.5 and 5.6. So let's talk about how this is going to work. So what we're specifically going to be looking at is we're going to be looking at the multiplication rule. And we'll talk about permutations, combinations, permutations with non-distinct items, and computing probabilities with permutations and combinations. All right, so this may take us today and the next class. I don't know how long this will take, but we're going to be talking about, essentially what we're going to be talking about here is we're going to be talking about counting. Now, you're probably saying, well, hold up a second. Professor Chibs. Counting, I know how to count. That's 1, 2, 3, 4, 5, 6, 7, 8. I said, yeah, that's counting, all right. But in this case, we're counting based on scenario, okay? How many ways to particularly do a particular task. That is the counting that we are going to be looking at here, besides just the regular 1, 2, 3, 4, 5, all right? And so the way to do certain tasks or certain things will factor considerably in talking about probabilities for certain scenarios in those situations. And that's where we're going to use, say, this multiplication rule and applying that to, say, permutations, combinations, and whatnot. Now, let's talk about this here, first and foremost. Number one, what is the fundamental principle? Counting. Okay. So, here's how it works. If a task consists of a sequence of choices, in which there are P selections for the first choice, Q selections for the second choice, R selections for the third choice, and so on, then the number of ways the task can be done is P times Q times R times ... ways. So essentially, I'll put it this way. Here's a good scenario here. I'll show off a good scenario. So I'm just going to make a new one here. Okay, let's say, for example, you had ice cream flavors. Okay, so let's say you had ice cream. And you were asked, okay, can you make a cone with 3 flavors? So you could pick any 3 flavors that you wanted to. We'll pick, let's just say 3 flavors. Kind of important. So you can pick any 3 flavors here, but you had a choice of, say, let's say there are 20 flavors in this ice cream shop, okay? So there's 20 flavors total that you can select from. Alright, I'll show you how this works, and it's very, very easy. Just, again, we're just going to use logic here, alright? Alright, so here are 3 flavors. I don't care what flavors they are, but they have to be 3 different flavors. Fine. So how many choices to select the first flavor? How many choices do I have for the first flavor of ice cream as part of my ice cream cone? How many choices do I have? Not my odds here, Vince. In this case, tell me how many selections that I have. I have 3, only 3 choices. I want to make 3 flavors on an ice cream cone. This is true, Monopolo. But yes, I have 20 choices. So when I first start out, I asked the person at the front, I have 20 choices on the board. So I'm like, okay, I could pick one of those 20, but again, I have 20 choices. That's what I'm looking at here. All right, so you pick, maybe it's your favorite flavor. Like for me, mint chocolate chip or vanilla. Those are my 2 favorite flavors. But, so, okay. We have 20 here. Now, I picked the next flavor. All right. Cookie dough. I know a lot of people love cookie dough. That's fair. Cookie dough. A lot of people love cookie dough. So I picked the next, let's say I picked the next flavor here. How many choices do I have now? I can't pick the same flavor the first time around. All right, so I have 19. That's right. I have 19 flavors of which to select from. Again, because I'm given the restriction here that I have to pick 3 different flavors here. I can't pick the same 3. All right. And how about the third choice here? How many choices do I have for that third one? I have 18. Good. So let's multiply this together. All right, so multiply 20 times 19 times 18. And get 6,980. All right, so in this case here, there's 6,980. 600 and... All right, hang on a second. What do we get here? What do we get here? 6840? Is it 6840? Oh, yeah, that's actually true. Oops. Sorry. I'm just going off of what you guys say, so it's okay. All is forgiven. Easy enough. All right, so So what I want to express here is, what does 6840 represent here? 6840 represents the number of ways we can make a 3-flavored ice cream cone with unique flavors. Okay, so given that we have 20 possible flavors on tap. If it was the old Baskin Robbins, then it would be 31 flavors. So obviously Baskin Robbins barely exists anymore, but still. You select thumbs up, you betcha, buddy. All right. All right. Any questions about that so far? All right. Hopefully that's not too bad. Nope. All right. This is one of my this is a pretty fun section, I ain't gonna lie. It's a pretty fun section. Okay. Let's look at the my favorite. Let's look at the next one here. Let's talk about number 2. Number 2 is, what is factorial and its notation. All right. So one of the things that we're going to learn here very quickly is talking about factorial and its respective notation. Now the notation here is made by an exclamation point. So yes, that is an exclamation point, and yes, that is mathematical notation. Now the way it works is that we have n factorial here, with n with a exclamation point next to it. What's that going to equal? Well, that's going to be n times n minus 1 times n minus 2, all the way down to times 3 times 2 times 1. So you multiply all those numbers, whole numbers, no decimals, no fractions, no nothing, but just those whole numbers all the way down to 1, and then you find out whatever that product is at the end of the day. So as you see down here, 5 factorial is 5 times 4 times 3 times 2 times 1, which will be 120. We also have the property here that 0 factorial is not 0. 0 factorial is going to be 1. So it's a very unique property here for factorial. One that is used quite often when we look at some of these scenarios here. You'll see that sometimes we're going to use 0 factorial here. All right. So just to make sure that that's crystal clear in that regard. And we will be using factorial here to some degree in terms of actually figuring out the number of ways we can do something, as well as using it for probabilities. So we will see that here in both scenarios. Okay, now let's talk about the first situation where we can actually apply said factorial and where we may see these probabilities being factored in. The first one here is talking about permutations. What is a permutation? So that's question number 3 here. Now, a permutation talks about the number of arrangements of R things chosen from a pool of N things where order matters. Okay? So where order matters here at the end of the day. So the notation here, as you can see, is NPR. All right, and that's n factorial divided by n minus r factorial. In this case, repetition is not allowed here for something that would be permuted or underneath a permutation scenario. You're probably wondering, well, hold up a second. What does that mean? Well, let's look at that number there, number 47. Let's take a look at that example and see what we're talking about. Go to the book here. I need to make my way over there. I'm going to show this a couple different ways. So. All right. So a classic example here is going to be number 47. So let's do that together. All right. So a committee problem is, like I said, pretty classic. So let's take a look at this one here. 4 members from a 20-person committee are to be selected randomly to serve as chairperson, vice chairperson, secretary, and treasurer. The first person selected is the chairperson, the second the vice chairperson, the third the secretary, and the fourth the treasurer. How many different leadership structures are possible? Okay, so basically at the end of the day, from this 20-person pool, we have to select 4 of those people in order to actually met out the number of ways we can have a committee. But once one person is put into that particular position, that person does not qualify for any of the other positions on the committee. So if I select a chairperson first, for example, well, that person cannot be simultaneously the vice chairperson, secretary, or treasurer. They're stuck in that position, and that's it. All right? And so, in this case, this is why permutations actually apply here. All right? Permutations apply here because order definitely matters. People who are selected for each particular position, since I can't put them back in, again, it's going to matter exactly how each person is meted out and where they necessarily go in our committee. All right. So in this case here, we have 20, and we're permuting 4 people because we have 4 positions in this committee. All right. Now let's go back to our formula here for just a moment. All right, so here's our formula. All right, so using our formula here, we're going to have 20 factorial over 20 minus 4 factorial. Now, you'll see something interesting that'll happen here, and this is clearly by design, by the way, and I'll point this out. Underneath permutation calculations, you have 20 factorial divided by 16 factorial. Now, if you, again, you do the 20 minus 4, and that's what you normally get. No problem. Pretty simple stuff. All right? Requires very little effort. Now, you can actually do this by hand if you wanted to. The reason why I want to show this here just a little bit is that 20 factorial is 20 times 19 times 18 times 17. And then you would have 16, 15, 14 all the way down to 1. Or another way to say 16, 15, 14 down to 1 is 16 factorial. And you divide that by, again, another 16 factorial. So you can cancel out 16 factorials, actually. And again, that leaves you with 20, 19, 18, and 17. Okay, so 20 times 19 times 18 times 17 is going to be the number of ways we can select a 4-person committee. Or, another way to look at this is, if you remember this first example here, how we selected our flavors of ice cream cone, well, that too is a permutation, because once we selected one flavor, we weren't allowed to go back to that flavor again for our second scoop. So this first example was also an example of a permutation about how to count things. You could do it the same way as we did in previous examples. You can go 1, 2, 3, 4. You have 20 people in the first spot, 19 in the second, 18 in the third, 17 in the fourth. Get the same result here. Just like so. The only thing that you have to determine is whether or not order is going to matter here at the end of the day. Does anybody have an answer for me here, really quick? (20 times 19 times 18 times 17? 116,280. All right. All right, that works. So 116,280 ways to select this 4-person committee from a pool of 4 people. Okay. There's one thing that we do have to show off here really fast. Let me bring that up too. Hopefully my computer doesn't totally crap out, but we'll pray together that this does not. Okay. Now, if you have your graphing calculator here, I'm also going to show you on the calculator how to do permutations. We'll also do combinations on the calculator too, guys. So don't worry. You can also do this on the calculator as well. Let's talk about how you can get the permutations to work out here as well. Now, if you notice, we have 20p4 here. Again, to reflect 20 permuting 4. We got 116,280, 116,280. So here's what I would like you to do. All right, so the first thing I would like you to do here is just type in the number 20 in the calculator. So go ahead and just type in the number 20 in the calculator. Old school, new school calculator, doesn't matter. Same way both ways. All right, so we type 20 on the calculator. Then, next, we go ahead and hit the math key. So we hit the math key here. And in this case here, I'm going to put this in chat. So I want this. So I want to go to math and PROB, okay, which says probability. All right, then select option 2. Notice we have NPR here. Notice that is the exact notation here that we're looking for, okay, for permutations. I'm going to select option 2 here in this instance. And notice it'll put it into format, or if you have the old school calculator, you'll see 20 and then the NPR and whatnot. So you have 20 NPR like this, and then for old school calculator, and then you'll have 4 next to that. So, and then we get the same answer here. Let's see. Ghetto. Hey, Ghetto. How you doing, my friend? Sorry if you want to be late on tangent. Curious your take as a math guy. Generally speaking, do you take the approach that math is necessarily the way it is and is real, or the opposite view that math is just a useful illusion? I don't think math is a useful illusion if it's accepted. The way I feel that math is, Godot, is math is a quantification. Again, a structured quantification that is accepted by a majority of humanity. And again, I believe because it is accepted and it is a way to quantify things that makes things more understandable, it is real because we decide it to be real. I do not believe it to be a useful illusion. It is real. We put a quantification on something in order to make it measurable in some form or fashion. And as long as you make it real, then it's going to be real. And that's basically how it is. That's how I think anyway. I think math is real. It's just, again, it is a way to have it understandable by society or the world as a whole. Is the best way to kind of put it. Of course, if you were to look at, say, let's say we were to meet an outside extraterrestrial or extraterrestrial civilization, then you know, they would have a different way of necessarily putting together their version of mathematics, and essentially it would be real to them that would be the way that they would go ahead and understand their version of quantification. But in both cases, it's real because it is an accepted form from the society as a whole. Hopefully that answers that question. I do not believe it to be a useful illusion. Not that I disagree, but plays devil advocate the notion that using different axioms than is often used, you can come to different conclusions than that is normal, such as there being proofs on YouTube, such as... That's true. That's very true. But one of the things... Yeah, absolutely, Vince. Yeah, we could absolutely take... Oh, yeah, I've been over the 1 hour mark. Hang on a second, Ghetto. Yeah, let's take a small break, guys. We'll come back at let's take a small break. We'll come back at 12:15. Okay, 12:15. We will come back here. All right. Sorry about that, everybody. I do need to take a break for you guys. We'll come back at 12:15. Let me put the B. Let me go to the big screen here for Godot. If I were to look at it this way, Godot, I would be like, at the end of the day, those ways to kind of those are different perspectives to look at the same thing. On one hand, it could be like in English where you have a homonym, right? Where you have like a word that's spelled the same but sounds different and has two different meanings. That's kind of like the same thing that we have here in this case, where you have 1+1 and we have a conventional way of looking at it, right? But a different perspective says 1+1 is a completely different thing, such as 1+1 in modular arithmetic has a completely different meaning than 1+1 in using, a base, a different base, for example. But even base arithmetic, and not even just maybe modular arithmetic, or it's just two different perspectives of two different things, right? But they're both fair underneath the axioms that you use. So I would say first you change your perspective, and then you apply whatever the axioms say, and then you get a conclusion based off of that. But they're both valid in their own respects. And it's fine. It's fine to come to different conclusions because you're already looking through two different perspectives. I don't think that's such a wrong thing. Well, aren't you making equivocation as that everything's always equal? I mean, that's one thing. Greek is a language, Socrates is Greek, therefore Socrates is a language. I mean, that is a fallacy, yes. And by logic, that's a fallacy. It doesn't work that way. We both know that. And besides, Socrates being Greek is a citizen of Greek, but again, it doesn't imply language at all. Again, context matters. You know that better than I do, Godot. Context and perspective. 100% one of the most important things when it comes to anything that we do, or any science, or any philosophical argument. Perspective is always the first and most important thing to actually take into consideration. So, because based on what you've said here, of course, Greek is a language, Socrates is Greek. You know for a fact that that's not, that's a complete fallacy. Yeah, exactly. When you change perspectives, then suddenly you look at things differently and you talk about that same thing differently. If we painted a broad brush of everything, if we painted a broad brush and we always said 1+1 was 2, well, then that's too big of a broad brush when I know for a fact that's not true. So I know for a fact that, again, if I look at modular arithmetic, I know that 1+1 isn't 2, depending on what I want to look at. So, because I can change the definitions. Every perspective is going to come out to possibly different conclusions. And that's the nicest part, actually, is being able to explore those different perspectives and reaching different conclusions. But in no way, shape, or form does it mean that they're contradictory. That's the one thing that you have to understand. It means within that space, it works for within that space in that particular perspective. Sure. 1+1 can be also equivalent to 3+5, which can also be equivalent to 0. Take a perspective here. Now, we all know based on the basic perspective that 1+1 is 2. But let's go to the big board here for a second. If I went with the idea, let's say I came into a perspective here for just a second, Godot, and I said, all right, if I looked at modular arithmetic here, let's say mod 2, right? Underneath modular arithmetic, specifically mod 2, I say, okay, what are the rules for mod 2? the perspective I'm looking at here is no longer just looking at plain Jane numbers here. To some degree, I kind of am, but to some degree, I'm not. In fact, I'm looking at the remainder of that number after adding things together. So I say, all right, let's take 3 plus 5, for example. Let me take the individual numbers of 3 and 5. If I take 3 divided by 2, and I looked at it from a simple perspective, old plain Jane division, well, that's going to be 1, remainder 1. Now, I don't care what this number is. I don't care what this 1 is. The only number I care about is the remainder here. When I look at modular arithmetic, I only care about the remainder. That's what I care about. So 3 here, in my mind, from my perspective, is equivalent to 1. I look at 5. Let's say I do the regular old division here. I take 5 divided by 2. Well, that's 2, remainder 1. Again, I don't care if the answer is 2 up here. Who cares? I only care about what the remainder is at the end of the day. So, I would say 3 plus 5 is 1. Or 5 is 1, sorry. Now, I could also take a look at 1 plus 1. Now, by all rights, 1 plus 1 is 2. But underneath modular arithmetic with mod 2, I would take 2 divided by 2, and 2 divided by 2 is 1. But since I only care about the remainder here is 0. We all know that. So in fact, 1 plus 1 mod 2, because I'm looking at that perspective in particular, is equal to 0. So I can effectively say 1 plus 1 is 0. There you go. But again, looking at it from a perspective of a modular point of view. Again, a slightly different perspective means that it has a slightly different meaning, and that means that 1 plus 1 is 0 within that space. I can't make that claim. I now on this, I will point this out here, Godot. To be fair, I'm not going to talk about religion on the stream. That's not what I do. I'm not going to say whether or not I have a different belief of religious varieties. I think everybody's entitled to have their belief of whatever their spirituality needs to be. Is math capable of determining that? I honestly don't know. I can't answer that with a straight answer, and I can't tell you that. So I mean, like I said, I have my own spiritual beliefs and stuff like that, but if I were to apply math to that, I feel sometimes that there could be two separate entities. If you're trying to determine whether or not God exists or something like that, I honestly don't know. I can't commit to any answer here. I haven't even thought of it honestly in that way, because I kind of think of it as one is a spiritual thing, and one is more of a scientific approach. When those things, I think that they don't overlap that much at all. You can kind of say. So that's to the extent that I really would honestly would be comfortable talking about at the very least. Off stream, I could be more than happy to tell you. Off stream, I'd be more than happy to tell you. I have no problem. If we were to talk like on Discord, I'd be more than happy to tell you my my beliefs and stuff. I got no problem with that, but like I'm not here to espouse that kind of stuff on stream. So it's a divisive topic, but you're right. But I will say that everybody has their own belief. I respect that belief, and you are entitled to have that belief. And I'm not about to sit here and say you're right or wrong, because that is your own belief, and like your connection is your own personal connection to whoever or whatever you believe in. So I will not. I'm not here to criticize anybody in regards to that. Trust me on that. Yeah, that's fair to say, Sneaky. Everybody has a different way of their own Yeah, I would like to generally do that. Yeah, I don't like. There's things that I like if like in a personal setting. If you and I were like to sit across from each other, sit like sincerely, Godot. If we were to sincerely sit across from each other, I'll be happy to you know speak about whatever. I have no problem with that whatsoever. None. All right. I'll be like, hey, this is what I believe in. If you ask, you could be like, yeah, I just here. This is my Discord. Um, but if you ask, you'd be like, okay, I'll tell you what I believe in. But I'm not going to tell. One thing that I will tell you right now, at least if it comes to divisive topics of any variety, okay, is that I'll be happy to debate you on it, but I'm not going to insist that I'm necessarily right on that topic. I'm not here to argue with you on that topic. You have certain beliefs, I have certain beliefs. I want to understand your perspective, and I want to be able to digest what you're trying to say and understand where you're coming from. We may agree to disagree. That's certainly plausible too. In fact, sometimes that just happens to be the case. But I think civil discourse is very important, and having a healthy conversation is very important. But at no point in time, for example, it's the same thing I said to my roommates a long time ago. And my I said to my roommate a long time ago, I'm like, I'm never going to push my ideas on you. I'm never going to push my religion on you. I'm never going to push this on you. At the end of the day, what I would like you to do, and it goes back to like in this class, for example, when we talked about like misleading graphs, at the end of the day, and I sincerely believe this day, and I still follow the same principle, at the end of the day, I want you to think for yourself. I want you to come up with the conclusions for yourself and decide what you feel is best for you and what fits within the philosophy that you believe in. And then you can tell me about what you believe in, and we could have a nice healthy conversations and talk about it. And I'd be perfectly fine with that. And that's where I think people should be. It shouldn't be like one extreme end of the perspective or one extreme end of, I think that if we understand each other, we probably will meet ourselves somewhere in the middle. That's why extreme perspectives can be very jaunting for a lot of people, and why they get uncomfortable in terms of talking about the very divisive topics. I understand people are zealous, but I'm more along the lines of, hey, you came up with your conclusion. Tell me your conclusion. Hey, I'll tell you my conclusion. Hey, I'm sure that we'll be able to understand each other. We may, like I said, may never agree on the idea, but at the very least, it doesn't mean we have to be enemies either. One thing to understand: anytime you're in a philosophical argument with anybody at any time, it doesn't mean you have to be enemies because you disagree with each other, okay? That's not how it works. It means that you understand what the other side is trying to tell you, but it doesn't mean you understand what the other side is trying to tell you, and you understand their perspective, and they could just be equally as right as you are equally as right, because again, context matters, situation matters. That matters too. So everything has a place and time. This is true. Is that a tautology? Sometimes. I would say yes, that's a tautology. That's fair. That's fair. Everything has a place and time. That's true. I love listening to other people's perspectives. It's true. I do. I think a lot of people bring a lot of interesting things to the table. It doesn't necessarily have to be like I say that a lot too. To be fair, Ghetto, it is what it is. But I don't. If you talk to me on the personal, be like, hey, let me understand where you're coming from, and then we talk about it, and then we agree, disagree, whatever, fine. I'm a simple man. But one thing I will tell you is I'll just tell you like it is. I'm super brutal when it comes to just like telling you, here's what I think. Okay. There's one thing that people know about me very well, and that is that, ladies and gentlemen, I have zero, and I mean, um, I will tell you one thing. I have zero, call it zero tact. whatsoever. One thing that people get to know about me really quick. I will tell you like it is, and here it is. That is what it is. I found in my life that I get along most get along with professors and pastors. Yeah, I've gotten along with a lot of different types of people from many different backgrounds. I would say I've gotten along. I've actually attended church services before. Hey Yusuf, how you doing? I've attended church services. I've done the whole 9 yards. Heck, I'm not even Christian, but I've been to a Billy Graham crusade, been to a Pentecostal service a few times. Um, been to a mosque. I mean, I'm telling you, many different. When you're a teacher, you get to meet many people from many different backgrounds, and it's really kind of refreshing to hear um, people's situations and how we can find solutions to either discuss topics or find solutions when, say, students are having issues and they tell me about them. Like, oh, let's see if we can find a solution to that. How do I feel that both of the boys have joined their up? Let me tell you, the more the merrier, Yusuf. You're gonna join me soon. I know how it is, Yusuf. All right. Okay. Oh yeah. Okay. All right. We went a little overtime there. All right. Let me go over this next one here. I'm gonna show you. I'll show you off this next example here. All right. Let's look at question 4 here. Let's come back from the break. Question number 4. What is a combination? So, a combination here talks about the number of arrangements of R things chosen from a pool of N things where order does not matter. So let's say order does not matter whatsoever. All right? And again, we have this formula here, which is NCR, which is equal to N factorial over R factorial, N minus R factorial. Note, repetition is not allowed here. So again, order doesn't matter, though, whatsoever. Let's give a scenario here about where this is actually the case. So this will be our next example here. This example is not in the textbook. This example is my own. So I will show this off here. Need to go to this website here. Okay. Alrighty. So let me bring this up on screen. Boom. Alright. So here is the here is the Powerball website. Okay, so people are familiar. How many people in this chat here have played the lottery? Or maybe they've gotten scratch tickets, or maybe they've gotten, they played the Powerball. I don't know. Yeah, you've played Powerball before? Combinatoric math is incredibly important for AI. Then you can flesh out scenarios and you can have AI learn through combinatoric mathematics. To answer that question. Yeah, you've played Lotto. We played Lotto before. All right. So what we're gonna do here is let's talk about. No, just scratch tickets. That's fair. That's fair. That's fair. That's fair. All right. So let's talk about how this works. Okay. Again, winning the grand prize is pretty easy. Okay, that's really not too hard. You have to match all the numbers. Okay, it's okay. Maybe winning the grand prize is hard. All right, I ain't gonna lie. You have to get really stupid lucky. But let's talk about how they come up with odds of winning the grand prize. So you probably have heard the idea of how many, you have to, so according to this picture, you have to get all 5 of the white balls plus the Powerball in order to win the grand prize. All right, that's what you have to do. All right, and of course there's past drawings here. Okay, the numbers that are done here, they show you again states that you can play in and blah 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 blah. All right, in any case, let's talk about the rules here for how to win at Powerball. So let's look at Powerball rules. All right. All right, so where is the number of Powerballs here? There we go. All right, so it changes sometimes, so I'm like, okay. All right, so the way it works is you have this. How to play Powerball. You choose 5 numbers from 1 to 69 and 1 Powerball from 1 to 26. If you match the 5 white numbers from 1 to 69 and match the subsequent Powerball, you win the grand prize. That's fair. Now, probably what you've heard in the news before when jackpots get silly, ridiculously large is like, how do you come up with like 1 out of 270 some odd million chance of winning this Powerball? Well, that's exactly what we're going to explore here in this example. Okay? So let's talk about this here. So first of all, we have the white balls here from 1 to 69. Nice. All right. Then we have the Powerball here. The Powerball here is from 1 to 26. Now let's answer a question here. All right. Let's say, just for example here, that we have the white balls come out of the bucket. They do the bucket thing, and then of course they select the 5 white balls here. So we have, let's say they come out to be this. Let's say 1, 2, 3, 4, 5. Note, let's say we have drawings here that look like this. So let's say I have, maybe this is a scenario here that the white balls that fall out of the bucket could look something akin to this. Now I want you guys to answer this question for me. Is 1, 2, 3, 4, 5 the same as 1, 3, 5, 2, 4? Is that the same as 2, 1, 3, 5, 4? Are those the same, or are those different? Is 1, 2, 3, 4, 5 the same as like 1, 3, 5, 2, 4? They're different because order matters. Well, what about your ticket there, Vince? If you were to look at a Powerball ticket, are your numbers put in numerical order? Just on a regular lotto ticket, are they put in numerical order, yes or no? Let's look at a Powerball ticket. It's fine. Let's just look at a picture of a lottery ticket. A Powerball ticket, actually. That's fine if you haven't played. It's not a big deal. So here's what a let's take a look at this on this side of the screen. So take a look at this ticket here. Are those numbers written in numerical order? You take a look at this picture here of this person's random ticket. No, they're not written in numerical order? No? If you read from left to right? No? You're telling me that 16, 34, 35, 51, 54, those are not in numerical order? I mean, I don't... It's a tough one for me. Come on, guys. I hope so. Yes, they are. Well, that's okay. So go from left to right here. They are written numerical order. So if I were to say, hey, if the white balls come out of the bucket, right? All of these lists of numbers here are written numerical order. The Powerball is a separate thing. So we'll talk about that in a second. But 1, 2, 3, 4, 5. Now, if you would say 1, 2, 3, 4, 5 is the same thing as 1, 3, 5, 2, 4, if that's what came out of the bucket after, rotating all the numbers around, mixing around, and you pulled out 1, 3, 5, 2, 4, are those the same thing now? Is that the same thing? Does that match what you would have on your ticket? If it came out 1, 3, 5, 2, 4, would that match what you have on your ticket? Yes or no? The answer is yes, these are the same thing. In fact, all 4 of these scenarios here are exactly the same. Because on your ticket, if you are wanting to win, as long as you have those numbers on your ticket, it doesn't have to be in numerical order to win. You just need to have those numbers on your ticket to win. So 13524, if it says on your ticket 12345 and the balls come out 13524 or 21354, those match the numbers that you have on your ticket. Order does not matter here. That's why we're going to use combinations here in this scenario. So the problem with that is that this is why order doesn't matter here, because at the end of the day, we only want to count this one time. Any combination of 1, 2, 3, 4, 5, any which way 1, 2, 3, 4, 5 looks in general, we only want to count that once, and we don't want to count the rest of the repeats, okay? So order doesn't matter here. So once we count 1, 2, 3, 4, 5, any one of these other three guys should not be counted as part of our guides. All right? So that's why we need the extra thing here written. Let me go back to the handout here. That's why we write this extra r factorial here on the outside to remove those, multiple countings of the same thing, like 1, 2, 3, 4, 5, and its respective counterparts. Okay, so just letting you know, that's how that'll go. Lowy and Mediocre Steve, thank you very much for the follows. All right, so here's how it's going to work here. Can you explain simply why the odds of having repeat birthdays in a group are higher than we would expect? What's the size of the group? That matters. It depends what the size of the group is going to be. So if you have, it depends. If you have, it depends how many people are in said group. But again, you have a higher likelihood because you have a higher likelihood of overlap. That's why. If you have 366 people in your group, then you're going to have an overlap of 1. So the more people in your sample size, then the higher likelihood that you're going to actually have an overlap of birthdays. Also, holidays actually play an important part about that as well. If you think about the New Year, if you think about Christmas time, if you think about sporting championships is another one, are times where people will do the duty and then, of course, 9 months later, have a baby. So major events, typically 9 months after those major events, typically a lot of children are kind of born with that. I think a group of 30 has almost 100% chance of a match. There's a pot. Yeah, I could see that. I have to look a little bit more into that, but yeah, I could see that. I don't think it's 100. It's not 100% obviously because they could have 30 different birthdays, but no, it's okay. That's not a problem, man. All right, so let's look at this scenario here. All right, so here we have 5 numbers here. All right, so what we're going to have here is, for the white balls here specifically, we're going to have 69 choose, and then we're going to pick 5 numbers here as part of our Powerball. Then we're going to multiply that by 26. Now, you could use this scenario here. You could do 69 factorial over 5 factorial, 69 minus 5 factorial. You could go ahead and do that here. That tends to be a little bit tough to do, but we're going to do 69 choose 5 times 26. We normally say choose when we talk about combinations, so I'll just point that out here in this case. Now, if we're doing this via the calculator here, which is going to be significantly easier in my estimation, let's go ahead and see what we get here. So we get 69. Again, hit the math key here. We're going to go to PROB for probability. We'll go to NCR here, which is, again, the number of combinations. Choose 5. Don't forget to hit the right arrow here if you have this scenario. This one. If you have the older calculator, you could just move on. But after this, 69 times 26. Again, why 26? Because we have 26 Powerballs here, which is a separate entity altogether. So we have 26 chances here. So 69 choose 5 for the first 5 balls. Okay, that you have to match here. And of course, 26 for the Powerball here. So if we multiply that, so you see here we get 292,201,338. All right, have a good one, Sneaky. All right, so the chances of you winning the Powerball here is going to be 1 out of this 292 million number here. This is the number of combinations for this number of combinations in the Powerball game. All right, and the chances of you winning is 1 out of that 292 million. So if we were to look at the actual odds, it's very astronomically low of winning. Of course, you could probably already guess. It's pretty low. Oops. Oh, supposed to hit that. So the odds of you winning is 1 out of 292 million. Which is 3.42. I'll kind of paraphrase here. 3.42223 times 10 to the negative 9th power. So, yeah, it's pretty low. So that would be 0. How many? That's 9, so that's 8, so that's 6. All right, so 1, 2, 3, 4, 5, 6, 3, 4, 2, 2, 3%. Yeah. All right, so this is the chance of you winning the Powerball jackpot. Is that low? If you're talking percentages, it's pretty bad, I know. But hey, that's just part of the deal. So, you know. But hey, if you want to try, hey, nothing wrong with that. Can't win if you don't try. Any questions about that? Nope. Oh, well, that's not too bad. All right. Now, if you have played scratch-off tickets, scratch-off tickets, of course, have different odds associated with them. They're on the back of the scratch-off tickets. In fact, one thing, if you do play scratch-off tickets, you can actually kind of affect your odds in your favor. Kind of, I say. I won't say definitely, but you can kind of affect your odds in your favor here. For example, underneath the Illinois Lottery website here, specifically, we go there for just a second. I'll showcase this off here for just a moment. What you can do is you can actually look at by Illinois law, you can see the prize pools for each instant scratch-off ticket. So let's see if I can find it here. All right. So you can talk about claims and have this here. It's probably tougher to find now. Let me see if I can find it here. Here we go. Unclaimed instant ticket prizes. So that's kind of down here. You can find every game that's underneath the Illinois Lottery, for example, and see how many unclaimed prizes that there are. Now, some of these are going to be brand new, like this Holiday Cash one is brand new. But, of course, all the prizes are available. But some of them could be in circulation, and then you can see exactly how many of the unclaimed prizes are in that pool. And then if there's a lot of those prizes in that pool that have been unclaimed, that means you're going to have possibly a higher probability of actually gaining a prize when you buy that particular instant ticket. Is it a guarantee that you're going to win? Of course not. If I said that, that would be a lie. All right, definitely that doesn't guarantee you're going to win. What it means is that you can also scout out tickets that aren't very good, and you could say, I'm not going to buy any one of those for $1 or $2 or however much you're going to spend on instant scratchers. So for example here, this one is not a good one to use because there's only one grand prize out of the $10,000. So maybe this is not the one here with the very small prize pool. There's a lower likelihood that you're going to actually get a prize out of that particular instant scratcher if you were at the gas station. So maybe that's not the best one. Maybe you want to pick ones that are a little bit newer that have a few more possible top prizes to actually be had at the end of the day. So something that you can certainly keep in mind. This is an unclaimed instant list that covers all games, and they're required to update this every single day. So should you want to strategize before walking into a gas station, grabbing an instant cash, instant ticket, well, you can go ahead and you can strategize beforehand and see if the odds are ever in your favor. One can hope. So, all right. Okay. So, any questions? Any questions? Anybody over the previous example? Any questions? Okay, so what we're going to be doing here next time is we're going to be doing a few more examples here. We may do another example or two from this particular section. All right, so to kind of make sure we get the permutations, combinations down, there's a couple more examples I definitely want to go over. All right, and then we'll also talk about the few more questions here from this handout that we'll certainly talk about here as well. Not this handout, but this one. All right, so we'll talk about a few more questions here from this handout. We'll have one more here. Should we complete the homework here before Thursday to stay on track? Yes. So if you're keeping pace here, Vince, get stuff done through section 5.5, 5.5, 5.6, because 5.6 is like a review section. So that's probably where you want to be for next time. Okay. So, all right, everybody. Great job here today. All right. I want to thank everybody for coming into this stream once again. Do I have office hours tomorrow? How do I join them? Victoria, I definitely have office hours. I have office hours right now, right after this class. This is my Discord here. Let me put the Discord in chat. So that is an invite to my Discord. You can go ahead and click on that, and you will you'll have a direct access to my Discord. So I'll be on tomorrow. Tomorrow is Wednesday, so I'll be on Discord probably. Victoria, I'll probably on because I have to do a class in the morning, so I think I will be on at like 11:30 noonish, if that's okay. Because I'll probably be coming back home after my class, so I'll be 11:30 noonish. Fine, somewhere around there. If that's fine, we can meet then if you like. Okay, cool. I'll be on at 11:30 noonish, and we can talk about any questions that you may have. Okay. All right. All right. Anybody have any more questions? Otherwise, we'll just head out. All right. Thank you so much, Jasmine. Take care of yourself. All right, everybody. Well, like I said, I want to thank everybody for coming out here to stream once again. We are going to come back here Thursday once again. All of you are absolutely lovely people. I hope that the microphone has worked out well. I think the microphone does work out well. It means I don't have to muddle around with fingers. Anyway, I digress. All right, thank you so much, everybody. We'll see you on Thursday. And as always, everybody, stay safe, stay healthy, but most importantly, stay safe. All right? Take care, everyone, and we will see y'all later. I have office hours right after this, so if you want to talk to me on Discord, I'm right on Discord, or feel free to email me. All right, have a great one, everyone. We will see you later. Take care of yourselves, everyone. All right. Bye. Bye, everybody.